Hello everyone. So today in this video we are going to solve a question of LeetCode, that is trim a binary search tree. This is 669 question LeetCode and this comes under medium category. Alright, so let's start with the problem statement. Given the root of a binary search tree and the lowest and highest boundary as low and high, trim the tree so that all its elements lies in low, high. So basically we need to trim this tree such that all the values of nodes lies in this range. Trimming the tree should not change the relative structure of the elements that will remain in the tree. So basically, the structure of this tree should not change after trimming the nodes. So basically, this statement says that the left elements and right elements, they should remain as it is. Okay, and it can be proven that there is a unique answer. So return the root of the trimmed binary search tree. Note that the root may change depending on the given bonds. So basically in this question we have given a binary search tree and we need to remove all those nodes which does not lie in this range. Alright, so the basic approach which we are going to use here is DFS approach. So in the DFS approach, what we will do, we will traverse through each node and check whether that node comes under this range or not. If it does not comes under this range, we will just update the previous node with the next node. Alright, so let's quickly understand the problem, and I hope the problem statement is pretty clear to you. Let's quickly move to the coding part and we will just understand each step here. Alright, so let's start. If root is equal to null, let's say if root is null, we will be just returning root from here, or we can say directly return null from here. Otherwise, let's check if the node is lies under this range or not. So let's check if root value is greater than equal to low and root value is less than equal to high. So basically we are checking here whether the value of node is under this range or not. Alright, so if it is under this range, we will just move forward. So root left is equal to trim bst root left low and high. We are just using a recursive call here, and root right trim bst root right low and high. I hope you are able to understand these both of the statements, because these are basically the common statement which we use in DFS to traverse the binary search tree. Now if the node value is not under this range, so what we will do, let's see here. Else if root value is less than low, let's say the low value is 1 and the node value is 0, so what we will do, we will just move on to the next node. So how we will check here, as we already know, there is a property in the binary search tree that, let me write here, the value of left part is less than the value of root is less than the value of right part. Okay, so when the value of root, alright, like in this example low is 1 and the value of root is 0, so what we will do, we will just ignore the left side because the value of left side is definitely less than the low, so we will just move to the right side. So let's return trim bst root right. We will just move to right side, so low and high. Okay, otherwise if the root value is greater than high, okay, let's say in this example the node 4, so high value is 3 and the value of node is 4, so definitely the right part is having the greater value than high, so we will just move on to the left part. So directly return trim bst root left from here, left low and high. I hope you are able to understand these statements, and at the end return root from here because we need to return the trimmed binary search tree. Alright, Now let's try to run it. I hope this should work fine. There is an error. Okay, we did a spelling mistake here. Yeah, it's working fine. So let's just submit it. Yeah, it's working fine. So let's calculate the time and space complexity of our solution. So the time complexity of our solution is big O of n because we are traversing through all the n nodes, and space complexity is also big O of n because in the recursive or we can say in the DFS approach, there is a recursive stake which is stored around big O of n space. So the space complexity is big O of n, and time complexity is also big O of n. So I hope the approach and solution is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video and subscribe to our channel. Thank you.